Benefits and costs in a project occur over time, and they typically occur at different times. For example, if a project involves planting trees, then looking at the benefits, there are really no benefits at the start. Then some benefit when the trees start to grow, but not too much, until they get big enough to provide shade and windbreaks, and then the main benefits is later on when they're harvested. On the other hand, the costs occur largely up front. There may also be some maintenance costs at different times, and then a harvest cost. So the timing of the benefits and costs can be quite different. So here's a stylized representation of that. This graph shows the benefits and how they might occur over time for a project that involves growing trees. They're very small at the start, they get bigger and they then stabilise, and then finally they are big at the end when the trees are harvested. So these intermediate benefits are from things like shade and shelter, but finally there's a big benefit at the end when the trees are harvested. And this is a stylized representation of the costs. So at the start there's a big cost of establishing the trees, there's maintenance cost every few years after that, and there's a medium-sized cost at the end when the trees are harvested. If we put those two things together and put them on the same graph, you can see that they really follow quite a different pattern. And if we subtract the cost from the benefits, we can get the pattern of net benefits over the life of this project. So in this case, we've got a big cost up front, we've got small benefits each year after that, and we're hoping that those benefits will add up to be enough to outweigh the initial upfront cost. This sort of pattern is typical. The costs and benefits of projects commonly follow a case where there are costs high early and benefits higher later on for all sorts of projects. But more generally, costs and benefits always follow different patterns over time. They don't have to follow that exact pattern, but there's always differences. Why does this matter? Well, it matters because you shouldn't just compare the total costs of a project and the total benefits of the project, ignoring the timing when they occur. And the reason for that is that if you just add them up in that simple-minded way, you're missing one of the costs, and that is the opportunity cost of capital. What this reflects is that to do this project, you have to give up some other investment. So there is a cost, an opportunity cost. This is the opportunity cost of using the capital to do this project. And it's like an interest rate being charged against this project. Here's one way to think about this. Imagine that there's a bank account devoted to the project that you're evaluating. The bank charges interest when the account is in debt, and it pays interest when the account is in credit. And the question we're interested in our benefit cost analysis is there a positive balance at the end? Do the benefits at the end of this time period outweigh the costs, factoring in the interest payments or the interest receipts, bringing in this extra factor of the interest? Here's an example. Suppose that at the start of a project there is a cost of $100. So the start of the project we'll usually call time 0, and the bank balance at time 0 in this case is minus 100. There's an interest rate of 5% per year, so in year 1 you have to pay the bank $5 interest on top of the $100 that you've already spent. So the total cost of the project grows to $105. Or the bank balance, this notional bank balance, grows to minus 105. In year 2, you have to pay interest on that $105. So the balance now grows to minus $110.25. By year 20, this negative balance has grown to $265 because of this accumulation of interest over time. What that means is that if the benefit of this project only occurs in year 20 and there are no prior benefits before that, then the benefit in year 20 would have to be at least $265 to outweigh the $100 plus all the interest costs that have accumulated up to year 20. Another way of thinking about this is called discounting. Discounting is essentially the reverse of calculating interest. Instead of increasing benefits and costs as we move forward in time, discounting decreases them as we move backwards in time. This might seem a little bit less intuitive than the bank balance way of thinking about this, but in practice this is how economists usually do it. We like to calculate the present value of a future benefit and cost because it allows us to express everything in terms of current values. And we could easily do a comparison in terms of current dollars. It'll reach the same conclusion as the final value, the bank balance approach that I described earlier, but for some purposes it's a little bit more intuitive. To calculate the present value of a future cost or benefit, this is the formula that we would use. So the present value is the future value at a certain time t times 1 divided by 1 plus the interest rate or the discount rate to the power of t, t being the number of years in the future that this cost or benefit occurs. So FV is the future value, PV is present value, R is the interest rate or the discount rate, and T is the time in years after the present. Out of this formula, let's grab one bit of it, that bit on the end, because that's got a particular name, that's the discount factor. This 1 over, in brackets, 1 plus R to the power of T is the discount factor. Because this is the thing that we're going to multiply future costs and benefits by to bring it back to a present value. Because R is bigger than 0, 1 plus R is bigger than 1, and so 1 divided by 1 plus R to any power is going to be less than 1. Here's an example. If the future value in 5 years' time is $1,000 and the discount rate is 5%, what's the present value? We have that formula. Present value is future value times 1 over 1 plus R to the T. Let's put the numbers in. So that's $1,000 times 1 over 1.05 to the power of 5, because it's 5 years in the future. And if we do the sums, which you can see how they're done on the screen there, we can calculate that the present value of $1,000 in 5 years' time is only $784. It's not saying that it's actually shrunk, it's just saying that in order for something to be worth $1,000 in 5 years' time, you could start with $784 now and allow it to accumulate interest over time and get up to that $1,000 in 5 years' time. The discount factor clearly will fall over time, because the larger T is, then the more years you've got for this interest to accumulate, so the more you're going to discount future benefits and costs back to the present. So here's an example where we've got different values of T from 0 through to 30. You can see what, in the middle column, what 1.05 to the T is. That's growing, but 1 over that 1.05 to the T is shrinking because it's divided by a bigger number. And so the discount factor is getting fairly small. You can see that by the time we get to year 30, the present value of something 30 years in the future is only 23% as large as its nominal value in that time frame. Now, how do we use this to evaluate an investment? Well, it's pretty simple. We convert every benefit and cost to a present value. We add up all the present value of the benefits, we add up all the present value of the costs, and we compare those two. So it's pretty straightforward. To convert benefits and costs to a present value, the little table in the top right shows us how this is done. So it's the first 3 columns are the time, the future benefits, and the discount factor. And then the present value of benefits in the last column is just the future value times the discount factor to give you a present value. And then we add up those present values to give us the total or aggregate present value of benefits. Key points. In a project of pretty much any type, benefits and costs occur at different times. Typically or commonly, costs are higher early and benefits are higher later. The timing matters because of the opportunity cost of capital and some other reasons that I haven't talked about. I've given you one way, an intuitive way of thinking about the problem, which I call the bank balance approach, but I've also explained the discounting approach and said that that's equivalent, and it allows us to compare the present value of benefits with the present value of costs to do our benefit cost analysis.